our group's teaching inquiry, we were given the topic energy. We wanted to focus on kinetic energy since there are many different forms of energy. Before having the class start the experiment, we decided to have a little group discussion first. By allowing the students to actively participate gave us a better understanding of what they already knew about the subject. Then we wrote their responses on the board to the question, what characteristics does matter have on kinetic energy? Some examples were mass, volume, and speed. From here, we told the class that they were going to test one of these variables with the given materials. We provided the class with Play-Doh, different sized rocks, a cup of ice, and a yardstick. Then we wrote the complex question on the board. What characteristics of matter affect kinetic energy? Next, it was time for the students to begin conducting their experiments.
At first, the groups were a little unsure of what to do. They wanted to roll or throw the rocks at a Play-Doh wall, which was what we originally thought as well. After asking them questions to get their minds rolling, they realized that in order to keep the experiment constant, they needed to drop the rock rather than throw it. It was interesting to see that their thought process was the same as ours. 3 groups chose to test how mass affects the kinetic energy by changing the size of the rocks. And the last group tested speed by changing the height that the rock was dropped from. And no groups tested temperature.
What do you think what claim are you going to make?
Well, claim is the greater mass, the greater the kinetic energy.
So what do you think is going to happen to the Play-Doh then, the bigger the rock?
The greater the mass, the bigger, the bigger mold.
Right. Okay.
You know how many times we have to do that?
No, because they have to go. They said they drop it pretty higher up. So.
Maybe you should move the Play-Doh.
It didn't make any difference.
Well, it's not necessarily going to because it's a small rock.
Okay. Ah!
That one did.
Do you have a yardstick?
Do we have a yardstick?
Woo! That one really counted it. Okay, so.
Sorry, where do you want to do it from? Like, I don't know.
Are you keeping everything else constant though?
Here, you drop both of them, because then you know how, okay, here, give me. We'll move them closer to you so you can make sure.
There are yardsticks too, if you want to make sure you have the same.
I would say. Yeah. You ready? 1, 2, oh, see, look at that one. Yeah, take a. There's the indent there. There's the indent there.
So what's your claim?
Our claim is that the greater, while keeping the distance the same, while the potential energy, I don't know, but the kinetic energy is greater for an object that has more mass.
Okay, so what did you do by keeping the height the same?
We maintained a constant variable and only changed the mass.
As you can see in these videos, the groups were very excited to see that their claims were correct when the rocks made indents on the Play-Doh. This proved to them that mass and speed of an object affects its kinetic energy. It made us very happy to see that they were genuinely interested in what they were learning.
By doing this inquiry lesson, we learned that through trial and error, you can learn to see things differently. We also found out that it's okay to be wrong as long as you investigate why you were incorrect and change your way of thinking to find the right answer. We discovered things that we should do in our future teaching, such as making learning fun. We saw that the Play-Doh kept them interested without being too much of a distraction, which is important when teaching young students. The idea of hands-on learning and the effect it has on how students understand scientific concepts is very important, because often it's hard to visualize these complex subjects. In the beginning, we didn't quite understand the point of this assignment, but after conducting this inquiry lesson, not only did we see that the students learned something, but we as teachers learned as well. This activity gave us an idea on what we will be doing in our future careers and allowed us to grow as future educators. Okay,
As you can see in these videos, the groups were very excited to see that their claims were correct based on their evidence. When the rocks made, start again.
By doing this inquiry lesson, we learned that through trial and error, you can learn to see things differently. We also found out that it's okay to be wrong as, no!
This is a practice run. It's not for real.
Okay, because I do part
This
of
is
the
just practice.
Okay. By doing this inquiry lesson, we learned that through trial and error, you can learn to see things differently. We also found out that it's okay to be wrong as long as you see, the wrong and the long is screwing me up. By doing, okay.